Here's an interesting question. This is a ball drop. Now you're going to see this question about 3 or 4 times in the upcoming podcast, especially when we get to infinite sums. That's in the next section, right? But it's a typical standard question where a ball is being dropped from a height of 2 meters. So here's your ball being dropped, and here's the floor. So there's your ball here. It's going to drop to here, bump, and it's going to keep on going. Now, what's interesting is this ball doesn't go back to the original height of 2 meters, because that'd be kind of silly, wouldn't it? That's impossible. You know, a ball, once it bounces, it rises a whole heck of a lot less. As a matter of fact, this rises only to 80%. That, in fact, is going to be the ratio. 80%, which works out to 0.80. There's your 80% right there of the previous height. That's your ratio every single time, because that's what you're going to multiply every height by. You're going to multiply every height by 0.8 to figure out the heights. Okay, now, here we go. We're starting at 2 meters. We want to know after how many bounces does the ball reach a height of only 33.5. Here's where the dilemma comes with these things. Number one, this is in meters. This is in centimeters. That's how I catch people every single time. So you have to remember that 2 meters actually works out to be 200 centimeters. That's its starting height. Here's the other thing that I'm going to catch you on right away. The other thing I'm going to catch you on is this right here. That is actually your T1. Your T1 is after the first bounce, not 200. After the first bounce. So you're going to take 200, you're going to multiply it by the fact it only bounces up to 0.8% or 80% of its height. You're going to get 160. That works out to be T1. And I can't overstress this because everybody uses the wrong T1 when they first do this, and they can't understand why their numbers are not working. So T1 works out to be 160. That's where you're going to start. So this thing's going to continue to bounce, and then bounce and bounce and bounce and bounce and bounce. You want to know which one is going to give you 33.5. So in other words, which bounce, which Tn, which bounce is going to give you that value. Aha! So this ends up being a Tn equals to T1 r to the n minus 1 question. Very simple, very straightforward. Tn, 33.5. Okay? T1 is going to be your 160. Your ratio, well, we figured it out, 0.8. So you want to know what is n. Okay, well, we got to do a little bit of math here in order to put this into our calculators eventually and figure it out. Divide by 160, divide by 160. So 33.5 divided by 160. Let's go. Oh, second quit. 33.5 divided by 160 first works out to be 0.209375. Ooh, what a mess. Okay, so that works out to be 0.20, okay, extend the page here, 0.209375 equals to 0.80 to the power of n minus 1. Now, how do you solve this? Same way we did it before. Let this be y1, let this be y2. Throw it in the calculator and let the calculator do the work. Okay, so let's boot this up. Oh, okay. Go into our y equals 2. First thing that we're going to put down is the 0.8 to the power of x or n minus 1. Okay? Second thing that we're going to put in here is what it's going to equal to, 0.209375. So those are your two things that we've got. And those are the two values that we've got here. There's our y2, there's our y1. Let's graph this thing and let's see what we get for an answer. Graph. Oh my goodness, what is that? Okay, it's such a tiny, tiny, tiny number. It's going to be somewhere, the cross looks like it's going to be somewhere around there. You can see that the red line, you want the blue line to be below the red line. So somewhere around here, it's made its cross. I'm not sure where it could be. So that's when you just turn around and say, okay, find me the intersect. Okay, second calc, find me the intersect, which is 5. Here we go. The x is there. Hit enter, enter, enter. Let the calculator do the work. X ends up equaling to 8. You see it? Right there. x equals to 8. So let's go back here and say, all right, x then equals to 8. It's at the 8th bounce, okay? The 8th bounce. Now, I don't know what you're saying. Can you prove that? Can you actually prove that that works? Sure I can. Let's start for T1. T1 we know was what? 160. So I'm going to take my 160, I'm going to multiply it by 0.8. That's after my first bounce. So that'll give me my second bounce height. Then I'm going to take that, multiply it by 0.8. That'll give me my third bounce. Take that one, multiply it by 0.8. That'll give me my fourth bounce. Take that one, multiply it by 0.8. That'll give me my fifth bounce, and so on. Sixth bounce, seventh bounce, and then finally one more time to give me my 8th bounce. So all I have to do is go into my calculator, put in 160, put in 160 right here, okay? And I'm going to multiply every time by 0.8, okay? You ready? Here we go. Times that by 0.8. There's my second bounce. Times it by 0.8. There's my third bounce. Times it by 0.8. There's my fourth bounce, my fifth bounce, my sixth bounce, my seventh bounce, and finally my 8th bounce. And exactly what I've got is 33.55, which is exactly what I predicted here on my 8th bounce. There's 33.55, which is right in the original question. That done 2 ways figures out that that's my 8th bounce. N equals 2, 8.